problems related to definite integration quickly. So we'll see the one of the very trick is very much useful. If let's say any integral a to b fx upon fx plus gx dx, that is b minus a by 2. Okay, so basically you'd have to look something, these fx and fx, these are same, and the other function. So what is the condition? Important is condition. So what is the condition? You should know the condition when this trick is useful. So condition is whenever this gx is f of a plus b minus x. Whenever your gx is f of a plus b minus x, then we can directly use this trick. Okay, let's do some of the problem. So let's say 0 to pi by 2 sin x upon sin x plus cos x dx. Here we clearly observe that the sin x function is same. Let's check about the other function cos x. So basically what is f of a plus b minus x is sine of 0 plus pi by 2 minus x is nothing but the cos x, and which is clearly the this function. Okay, so that's why we can directly use it, and it says pi by 2 minus 0 by 2, that is pi by 4. Okay, so it's a pi by 2 by 2, that is pi by 4. Let's take one more example. So you should know that this f of, so numerator has only fx, denominator has fx plus gx, and one of the function is same as the numerator, other function is different, but the condition is that this different function, that is gx, should be such that f of a plus b minus x. If this happens, then we can directly write the answer as b minus a by 2. Okay, let's take one more example. 0 to pi by 2 root of sin x upon root of sin x plus root of cos x dx. This is also we can directly write as a pi by 4. Okay, the same as above, because this function is same as the root of, so basically here fx is root of sin x. Okay, so that's why we can directly write it. Let's take other example. 0 to pi by 2 tan x upon tan x plus cot x, same as above, because tan of pi by 2 minus x is, so basically we know that tan of 0 plus pi by 2 minus x is cot x, that is this function. That's why directly its answer is pi by 4. Okay, let's take one more example. Let's say pi by 6 pi by 3, same problem, tan x upon tan x plus cot x dx. Here this function is fine, we have to check this cot x. So how do we check? So let's substitute in place of tan pi by 6 plus pi by 3 minus x, that is nothing but tan of pi by 2 minus x, that is cot x, and which is the other function. So directly we can write answer is pi by 3 minus pi by 6 by 2, that is pi by 12. Okay, let's take few more examples for your expertise. So let's say the same problem, pi by 6 upon pi by 3 1 upon 1 plus root of tan x. Okay, now here you observe that directly, because if you assume that fx is 1, so fx is a constant function, we can't do anything. But if you do little bit of manipulation, so let's see what I am doing. I am just root tan x, I can write like this, 1 upon root of sin x upon root of cos x. Okay, so that is pi by 6 pi by 3 root of cos x upon root of cos x plus root of sin x dx. Now we observe a function what, fx is root of cos x, no? And what is f of pi by 3 plus pi by 6 minus x? That is what? F of pi by 2 minus x, no? That is clearly nothing but cos of pi by 2 minus x is sine x, and that is the this function. So directly we can write answer is, again, answer is pi by 3 minus pi by 6 by 2, that is pi by 12. Okay, let's take one more very good example, little bit different. So 2 to 4 log of x square upon log of x square plus log of 36 minus 12x plus x square dx. Okay, so here so here in this problem, how do we know that we can apply this particular trick or not? Is one of the function is fx, which is same, one of the function that is fx is same in numerator and denominator, and we have to check for the other function, okay, gx. So here it appears that this function is fx, which is same. We have to check about the other function. So what is this? So how do we check? Log of 4 plus 2 minus x square, no? Fx. So f of, basically what I have done, f of, so here we clearly, the f of x is log of x square. So what is f of 4 plus 2 minus x is equal to log of 4 plus 2 minus x ka whole square, and that is nothing but log of 4 plus 2 6 minus x square, that is 36 plus x square minus 12x, and that is clearly the this function. So directly we can say answer is 4 minus 2 upon 2, that is 1. Okay, let's take one more little bit difficult problem, but we can use this trick with some manipulation. So let's say this is log of 2 log 2 root log of 3 root x sine x square upon sine x square plus sine of log 6 minus x square dx. Now you observe that directly it does not seem that we can apply, because this is sine x square and this is x sine x square. So one of the functions should be same on the numerator and denominator, but it is not here. Okay, so little bit we can convert into this form by some substitution. So let's, if I substitute x square is equal to t, if I substitute x square is equal to, that becomes 2x dx is equal to dt. So what our function turned out to be, in place of log x, so x is equal to log 2, so it converts into log 2, no? Because we substitute x is equal to log 2. So what is t? T is log 2 root square, and similarly this is log 3 this, and x dx, so it is dt by 2, okay, by 2 into sine, so I am writing here, so this is dt, x dt, because x, this is x is here, dx here, so x dx is dt by 2. So basically we see that this x and dx, so x dx is dt by 2, so we'll put dt by 2, so it is constant, I put it outside, and then sine x square, so that becomes sine t divided by sine x square is again sine t plus sine log 6, so log 6 is a constant, we will not change, minus x square means t. Now we observe that whether, so now it seems that the function fx is same on the numerator and denominator, so we have to check what about the other function, whether it is satisfy or not. So we can say that, we can write, let's say fx is equal to sine t, okay, and what is f of log of 3 plus log of 2 minus t, that is nothing but f of log of 6 minus t, and that is what, sine of log of 6 minus t, and which is clearly the same as this function. So we can directly answer as a half is already there, because half was the constant, and this becomes log of 3 minus log of 2 divided by 2. That is the answer. Okay, if you want to simplify it, something log of 3 by 2 divided by 4. So that is the answer. Let's take one more problem for your practice. Say let's say 0 to pi by 2 dx upon 1 plus 10 to the power nx dx. Okay, now here also clearly we see that we can't write that there's something constant 1 which is not in the numerator and denominator, but as we see in the previous problem, we can write something like this. This 10 to the power nx will be sin x, so it is something, it is sin to the power nx upon cos x, so that become cos to the power nx, and this is also cos to the power nx plus this dx. Now clearly fx is cos to the power nx, and cos to the power n pi by 2 minus x is sin to the power nx. So we can directly write the answer is pi by 2 minus 0 by 2, that is pi by 4. Okay, so this trick is very much useful, but the condition we should know that one of the function is same and other function is different, but they should satisfy this condition. Okay, so let's see the proof. So why we are getting, let's see the quick proof why we are getting this formula. Okay, so this is just a proof to know why we are getting this trick or why we are getting this formula, proof of formula. So a to b fx upon, let's say this integral fx upon fx plus gx dx, and what is the condition? Gx should be f of a plus b minus x. Okay, let's use the property. One of the property of integration says, so there is a property of integration fx dx can be written as a to b f of a plus b minus x dx. So this is one of the property of a definite integration. Since gx is f of a plus b minus x, so we can also write before using this property, we can also write this I is equal to a to b fx upon fx plus f of a plus b minus x dx. Okay, because gx is f of a plus b minus x. Now we'll use this property of integration. So same integration can also be written as I is equal to a to b f of a plus b minus x upon, in place of fx, so equation 1, see the equation 1, upon f of a plus b minus x plus, if you substitute f of a plus b, so a plus b minus a plus b minus x dx. So it simplifies and becomes a plus b f of a plus b minus x upon f of a plus b minus x, plus that becomes this a plus b cancel out, that becomes minus and plus, that becomes f of x dx. This is the same integration I. So this is the I without using property, this is I with using the property of a definite integration. And if I add both, so adding 1 and 2, so if we add 1 and 2, that becomes 2I is equals to a to b. We see that we observe that numerator is, one case numerator is fx, another numerator f of a plus b minus x, whereas denominator is fx plus f of a plus b minus x. And in the second equation also the numerator is different but the denominator is same, so they becomes denominator is same, f a plus b minus x plus f of x, and denominator is same and the numerator is in fx and f of a plus b minus x. So we'll add both the terms, so fx plus f of a plus b minus x. Okay, now we clearly observe that the numerator and denominator is same and they cancelled out, and they will become a to b dx, and that is nothing but b minus a. So 2I is b minus a, hence I is equal to b minus a by 2. Okay, that is the proof. So why we are getting, and whenever you use any trick or formula, you should always know the condition. Sometimes we forget the condition. Okay, so condition is important. So this is the condition which is required to get this one. Okay, so this is the formula with the condition. You should know the condition is important.